Alright, so before going into my statistical analysis, I just wanted to go over a few packages I use to complete this project. First off, I use ggplot. This is a very popular R package that allows users to create complex R data visuals. It allows you to add a lot of layers to graphs too to kind of visualize data in a more customizable way than base R offers. Next, I use dummies, which is a very easy to use library for converting factor variables and categorical data into ones and zeros or dummy variables. Next, I used a library called CA Tools, which helps measure performance of logistic models. It offers area under the curve statistics as well as ROC plots. So before doing any analysis, I set a random seed of 100, and this allows anyone to run this script time and time again and get the same results. So I load in my HR dataset and store it as HR data. And given this dataset is quite large, it has over 14,000 records with 10 variables each. So to speed up my analysis, I selected a random sample using the sample n function from dplyr to randomly select 4,000 records for the remainder of my project. So just to get some initial observations of the data, I want to see what kind of variables I have. So using the glimpse function, you can see I have 4,000 records of 10 variables, and here are the first 10 or so values of each variable as well as the type of data it is. So you can see I have some decimals, some whole numbers, as well as factors. So the factors are what I'm most interested in here, as I'll have to keep this in mind when I go to do my logistic regression. They'll need to be converted. So I won't go through all the charts, I'll just run them. This is a chart I was really interested in because predicting whether or not an employee leaves is one of the focuses of my project. So here you can see it's about a 3-to-1 ratio of employees staying, this green, to employees leaving, which is the red. I also wanted to see if the departments were balanced in terms of employee count. So I ran this chart. They're fairly balanced for the most part. However, sales, support, and technical seem like they have very high counts of employees. This could indicate it's a technical company that has a technical product which requires a lot of sales, support, and kind of ongoing development and maintenance. Next is satisfaction level. So this is a good sign for the company. Most of the satisfaction levels are above that 50% mark, so it's a pretty good place to work, and actually a lot of the values are up here even in the higher 8 to 9 range. So that's, the employees seem to be really satisfied with where they work. So it's always important to see if you have any missing values in your data so you can kind of adjust your analysis and account for that. So I'm using this mismap function from the Amelia library, and what this will do is plot any missing records in my data with an orange bar. So let me run that real quick. So here's a good sign. This whole plot is white, which may not mean a whole lot, but the orange, if any of these records were missing, an orange bar would be at the row number of the variable that was missing. So you can see I have a very clean data set, which will allow me to kind of bypass that aspect of data cleansing process and go right into my model. So I mentioned the dummy package earlier for creating dummy variables for factors. So that's what I'm doing here. Sales is a factor. There's about 10 departments, and salary has 3 levels. It has low, medium, and high salary. So I'm converting those into dummy variables of ones and zeros based on what level that factor is. And then I'm combining it back into my HR dataset, so I have all those new columns now. And then after that, I just reassign my HR data to only the columns I need. I no longer need the original factor variables. I just need the dummy ones. So from there, I create my training and test datasets. So I'll develop my logistic model using the HR train dataset, which contains about 80% of my total records. And what this is doing is predicting the class left, which is a 1 or 0. If the employee leaves, it's a 1, or if they stay, it's a 0, by all other variables. So this is a logistic regression. It predicts a 1 or a 0. Next, I kind of want to see how my initial model does. So you can see quite a few of the variables are significant. We kind of saw that earlier with satisfaction level. Employees seem to be pretty satisfied. Number of projects, average monthly hours, all these things you'd probably expect to play a significant role in determining whether an employee leaves or not. So nothing too surprising from first glance. So now that we have our baseline model, we'll use the predict function to use that model to predict on our test data set whether or not an employee leaves. So let me just run that real quick to get our predictions. All right. So now we want to find the optimal cutoff point. So we'll use the area under the curve from the CA tools library. And what this will do is create an RC plot that tells us the optimal cutoff point to use for classifying our probabilities. Okay, so here you can see our optimal cutoff point that kind of minimizes sensitivity and specificity is about 0.8073. So now we'll use that probability to convert our predicted probabilities into that 1 or 0. So after that is done, I run a confusion matrix to kind of tell us how our initial model did. So here you can see we accurately predicted about 618 employees who actually stayed, and we accurately predicted about 2 employees who actually left. So this combines for an okay accuracy of about 78%. It's not as strong as we'd like. As you'll see in a future analysis, I run a random forest model to see if we can kind of improve our accuracy. So that's all for the logistic model at this time. Next, I was interested in seeing groups of similar employees. So I used the pvclust function from the pvclust library, and I plotted that. So this kind of takes a while to run. Pause the video. Okay, so now that finished running, let's kind of see the results. Okay, so this is pretty interesting. So I think we can see we have about 2 main clusters splitting at this 100% probability. So this is one whole group of similar employees right here. And then going off to this other split, we have another group of similar employees. So that's pretty interesting to see. We have kind of 2 distinct groups of employees in our data set. So after the cluster analysis, I conducted 2 ANOVAs. I'll just go through the first one as I feel like that's more interesting. So I was interested in seeing if the time spent at company on average, has anything to do with what department an employee works in. So let me just run this ANOVA. Summary. So you can see we have a very low p-value, which does indicate on average that at least one department has a different average time spent at company than the others. To visually see this, I created a kind of box plot. So you can see most of the departments on average do have that like kind of 3 to 4 year time spent, except for management and product management. They seem to have a little higher and a little less in some cases. The final part of my project was conducting a secondary model, modeling technique to predict left using a random forest. To ensure that none of my data was messed up in previous analysis, I brought in a new sample of that HR data, the same 4,000 rows, and just called it RF data. I again created my split and training test sets and created a model using the entries to 20 to kind of conserve computing power and save time. Next, I'll run a summary of the model. Okay. Then I use that model I just created, the random forest, to predict on my test set. So in order to see how this model performed, I ran another confusion matrix. Wow. So this model performed a lot stronger than the previous logistic model. We accurately predicted a lot more of the true positives. So we have an accuracy of 0.9862, which is about 99% accurate. This probably could have gotten much closer if I increased the number of trees, but we're pretty close, so it might have just been marginally more strength. So as you can see, the random forest model is the clear winner of the two models conducted in this analysis. To kind of further the analysis, I would probably tune the models and kind of split more of my variables to kind of get some more insights out of that data.